Normal distribution and sampling distribution. In this lesson, we will learn the normal random variable and its characteristics, how to construct normal curve, how to identify region under the normal curve, and how to compute and interpret results under the normal curve. So here are the characteristics of a normal curve. The normal distribution is a mathematical model represented by a bell-shaped curve, which is symmetric with respect to the mean. The normal curve does not intersect or touch the horizontal axis. The mean, median mode of the normal distribution are equal. The area under the normal curve is approximately 1 or 100%. The standard normal distribution has a mean of 0 and a standard deviation of 1. Those are the characteristics of a normal curve. And now, I'm going to show you the table of area under the normal curve. For example, we are looking for the area from z is equals to 0 to z is equals to 1.25. And then, we are going to look at the z-table and find in the column of z the number 1.2 from the given 1.25 and find the row number 5, and that's the corresponding value of 1.25 in the z-table. To draw the normal curve, you have to construct a bell-shaped curve like this. Then always remember that when you are drawing a normal curve, the middle always starts with 0, and the value to the right of the 0 is always positive and the left side is negative. Another point to remember is when the given z area to the left is positive, the operation that you'll be using is addition. And when it's to the right, you are going to use subtraction. And when the z area to the left is negative, you'll have to subtract and add if it's negative to the right. So going back to the given problem, area from z is equals to 0 to z is equals to 1.25. When you look at the table, the corresponding value will be 0.3944. Because the given z is positive, the shaded area will be to the right from 0 to 1.25, which is the slightly middle of 1 and 2, and the area will be 0.3944. Another example is area from z is equals to 0 to z is equals to 1.25. So always remember that even if the given z is negative, its value in the z-table will still remain positive. So earlier we got 0.3944 as the corresponding value of 1.25 in the z-table. Since the given is negative, the shaded area in our normal curve will be from 0 to the left of negative 1.25. When the given is area to the right of z is equals to 1.3, get the equivalent of 1.3 from the z-table, which is 0.4032. Since it's to the right and it's positive, you have to subtract 0.5 and 0.4032, and the answer will be 0.0968. And then the shaded area will be from 1.3 to the rest of the right side. Another example is area to the left of z is equals to 1.53. First, you'll have to get the value of 1.53 from the z-table, which is 0.437. Since it's positive and it is area to the left, we will be using addition. So 0.5000 plus 0.4370 is equals to 0.937. And the shaded area in the normal curve will be from 1.53 to the rest of the left side. Our last example is area between z is equals to negative 2.0 to z is equals to 0.9. First, get the equivalent of the z, which is 0.4772 and 0.3159. We will be adding these two since it's the area between negative 2.0, and 0. When you add the two values, the answer will be 0.7931, and the shaded area in the normal curve is between negative 2.0 and 0.9, or the area slightly before 0. Next, we will have word problems. And here is the formula and notations. X is equals to the score, U stands for the mean, O stands for the standard deviation, and Z stands for the z-score. So the formula would be Z is equals to score minus mean over the standard deviation. Here's our word problems. First, there are 500 students who took the entrance examination in all. If the average, which is the mean, score of the students is 80 and the standard deviation is 10, first find the percentage of students whose scores are number 1 from 50 and 80, number 2 from 80 to 95, number 3 below 75, number 4 above 85, and number 5 above 70. Let's solve our first word problem. First, let's find the percentage of the students from 50 to 80. By using our formula, z equals to the score minus mean over the standard deviation, let us substitute the value. So if the score is 50, the x will be 50, and then minus the mean, which is 80, over the standard deviation of 10. The answer will be negative 30 over 10 equals to negative 3. If the score is 80, so let's substitute the values to 80 minus 80 over 10, then the answer will be 0. So let's take a look at the table and find the equivalent of the z-score 3.0, and its corresponding value is 0.4987 or 49.87%. So there are 49.87% students who got the score of 50 to 80. Now let's find the percentage of the students whose score is from 80 to 95. We will use the same method, so let's substitute the values. So z is equals to 95 minus 80 over 10. And then z is equals to 15 over 10. And the answer will be z is equals to 1.5. Let's take a look at the table and find the equivalent in the z table of 1.5. The equivalent will be 0.4332, or so the answer will be 43.42% of the students scored from 80 to 95. Now let's try to find the percentage of the students whose score is below 75. Like what we did, we will just substitute the values. So z is equals to 75 minus 80 over 10. The answer will be negative 5 over 10, and then z is equals to negative 0.5. In the table, 0.5 is equivalent to 0.195. Since it's below 75, we'll have to subtract it from 0.5000, and the answer will be 0.3085, or 30.85% of the students scored below 75. Lastly, let's try to find the percentage of the students who scored above 85. Again, we will use the formula of z equals to the score minus the mean over the standard deviation. And now we substitute. So z is equals to 85 minus 80 over 10. And the answer is negative 5 over 10. So the answer will be z is equals to 0.5. Now let's find the equivalent of 0.5 in the z table. It will be 0.1915. Since it's above 85, we'll have to subtract it from 0.5000, and the answer will be 0.3085, or 30.85% of the students scored above 85. Now that we have solved all the problems in the question number 1, we will proceed to the number 2, which says that a company had decided to accept top 15% of the examinee. The test has a mean of 150, and a standard deviation of 20. Find the possible lowest score for an applicant to pass the first step of application. So the given mean is 150 and the standard deviation is 20. To solve, since the company will hire the top 15%, we're going to subtract it from 0.5000. So 0.5000 minus 0.1500 is equals to 0.3500. We will have to list the closest to the area of 0.3500. Let's take a look at the table. The ones that are closest to 0.3500 are 0.3485 with a z-score of 1.3 and 0.3508 with a z-score of 1.4. Since 0.3485 is the closest to 0.3500, we consider the z-score 1.3. Now let's substitute the values. Z is equals to the score minus mean over the standard deviation. So 1.3 equals to x minus 150 over 20. So let's transpose x minus 150 equals to 1.3 times 20. The answer is 26 and then transpose 150. So x equals to 26 plus 150. The answer will be 176. So the minimum score of the applicant should have 176. Now let's draw a normal curve. Since the mean is 150 with the standard deviation of 10, let's put 150 in the middle and then add 20 to the right and subtract 20 to the left. Since the answer is 176, the shaded part of the normal curve is from 176 to the rest of the right. So the minimum score of the applicant should have is 176. And now that you've learned about normal distribution and sampling distribution, try to solve this at home, given the normal distribution with a mean of 35 and a standard deviation of 6. Find the area A from 33 to 41, B 18 to 46, C above 20, D below 37, and lastly E above 30. I hope you learned a lot in this tutorial.
Thanks for watching!
The club isn't the best place to find a lover, so the bar is where I go. Me and my friends at the table doing shots, tripping fast, and then we talk slow. Come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop it, and the man on the jukebox, and then we start to dance. And now I'm singing like, girl, you know I want your love. Your love was handmade for somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. Last night you were in my room, and now my bedsheets smell like you. Every day discovering something brand new. Well, I'm in love with your body. 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 Every day discovering something brand new. I'm in love with the shape of you. When we came, we let the story begin. We're going out on our first date. You and me are thrifty, so go all you can eat. Fill up your bag and I fill up the plate. We talk for hours and hours about the sweet and the sour and how your family's doing.